Let's talk about variation. A variation simply means variables. And so we are going to be talking about the relationship that exists between two or more variables. We have the dependent variable and the independent variable. The dependent variable is that variable that depends on another variable. For instance, let's say we have y equals to 4x. This means that the dependent variable here is y, the independent variable is x. X can assume any value, but the value of y depends on whatever the value of x is. If the value of x is 0, it's going to affect the value of y. And so we have the dependent variable and the independent variable. There are basically four types of variation we are going to be talking about. The first is the direct variation, the indirect variation, which is also the inverse variation, joint variation, and partial variation. But we will talk about the direct variation in this class. The direct variation is about the relationship that exists between two or more variables in a particular proportion. That is, there is a positive direction between two or more variables, in the sense that an increase in one variable results to an increase in the other variable. A decrease in one variable also results to a decrease in the other variable. So the two variables are directly related. They are being affected by one another. For instance, let's say there is an increase in the sales of cars. There is an increase in the sales of cars. There is an estimation, an assumption that there will be an increase also in the sales of petrol. It is expected that most cars, or assuming that all cars use petrol. If all the cars use petrol, then an increase in the sales of cars will bring about an increase in the demand for petrol, because you need the petrol to move the cars. And so this is being affected directly. The demand for petrol is being dependent, or is being affected by the increase in the sales of cars. So there is a direct relationship between both variables. Consider that there is an increase in the number of students admitted in the school. We expect that there will be an increase in the revenue generated by the school, assuming that the school fees is constant, because there is always an assumption in every relationship between two or more variables. There is an assumption. So assuming that the fees is constant, then the more people you admit into the school, the more revenue you generate. The school fees is not being increased, it is not being reduced, the school fees remain the same. So the more people you admit, the more revenue you generate. In the same manner, if there is a reduction in the numbers of people being admitted in the school, then there will be a reduction in the revenue generated, assuming the fees remain constant. So there is always a constant. There is a constant proportionality in this case. Alright, so let's take some examples. If P is directly proportional to Q, if P is directly proportional to Q, that means P varies directly to Q. And so this symbol means directly proportional, or we say varies. So in case you see this means varies. P is 25 when Q is 7. Find Q when P is 15. And so the first thing to do here is to change this symbol to something operational. Change it to an equality sign. Once we change it to an equality sign, we introduce a constant term. Because in a relationship between two or more variables, there is this constant proportionality. So we introduce a constant term, and then we have our Q. It's important we write this here, where K is a constant. K is a constant. And so it says P is 25 when Q is 7. So with this equation, we can obtain an equation in terms of P and Q. Once we find that equation in terms of P and Q, then we can use that to solve all other types of problems. And so P is 25. This is Q times K times Q. Q is 7. So this is going to be 25 equals to 7K. The quotient of K is 7, so I'm dividing the other side by 7. So the value of K is 25 over 7. Now that we have the value of the constant term, then we can say that the relationship will be P equals to, I'm substituting that here, equals to 25 over 7Q. We can use this single equation to solve all types of problems in this particular question. And so, to solve the problem now, find Q when P is 15. Find Q when P is 15. So we substitute 15 equals to 25 over 7. We have that as Q. This is 15 over 1. So we can cross multiply this. This will be 25Q times 1. 25Q equals to 15 times 7. The coefficient of Q is 25. So Q will be 15 times 7 over 25. And finally, we are going to have this as 5 in 15. I mean 3 in 5 in 25. That's 5. 5 in 15, 3. So we have this as Q equals to 3 times 7, 21 over 5. And the value of Q is 4 whole number 1 over 5. Now, if W varies directly as the cube root of D, W varies, I told you that this sign means varies directly as the cube root, not the cube root of D. And when W equals to 10, D is 27. Find the value of W when D is 64. So I said, having written the statement, the first thing to do here is to change this symbol to something operational, that is something we can make use of. Change that symbol to equality sign. So this will be W equals to, once you change it to an equality sign, then you introduce your constant term. So we have this as cube root of D. And so we state here where K is a constant. We have to introduce that constant term. There is something that is constant. There is an assumption. So where K is a constant. So now we want to find the value of K first. W is 10 and D is 27. So we substitute that. W is 10. This is 3. This is K times 3. The cube root of 27. So 10 equals to, the cube root of 27 is 3. Cube root means what are you going to multiply by itself? 3 times. That will give you 27. That's 3 times 3 times 3. And that's going to give us 27. So the cube root of 27 is 3. 3 times K is 3K. And so the equation of K is 3. The value of K is 10 over 3. So we say that the law connecting there, the formula now will be W equals to 10 over 3, the cube root of D. We have just substituted the value of K here. So with this single equation now, we can solve all types of problems relating to this particular question. And so the question here is, find the value of W when D is 64. Find W when D is 64. So find W when D is 64. So we substitute the value of D as 64. So we have this as W equals to 10 over 3 times What is the cube root of 64? And that is 4. Cube root of 64 means what I'm going to multiply by itself 3 times, that will give you 64, and that's 4. 4 times 4 times 4, 64. So W equals to, we have this as 40 over 3, and the value of W is 40 over 3. 3 in 4, that's 1. Remember 1, we have this as 13 whole number, 1 over 3. And that's the value of W. Please click the like, subscribe button, and share with your loved ones. See you in the next class.